This video will describe the design and testing of a new taper slicing jig for the bandsaw. In addition, I'll demonstrate the slicing of some unique tapered joints. I was recently contacted by a customer who wanted to know if you can make longitudinal tapers on the Accu-Slice system. Tapers that you normally do on a table saw for making table legs. But he didn't just want to make tapers, he wanted to make tapered joints. And even more than that, he wanted to make a very specific taper joint. And this is the joint he was looking to make, where you have two double angles, then a centerpiece that goes in the center. And if you had two contrasting wood, this would make a very unique taper joint. Well, I'm always up to a challenge to try new things with the Accu-Slice system, so I set out to make a taper jig that could make these joints, but also could make tapered legs for tables. And this is the resulting jig I made. It uses our standard Accu-Sled 2, the 30-inch carriage, and I have an angle iron on here, which is about 30 inches long, and it's at an angle, much like an angle jig for a table saw. And then I have clamps on here to hold your board on this jig. So in this video I'll be demonstrating this jig for making tapers that you can use for tapered legs for tables, but also to make these unique joints. I designed this jig in the Fusion 360 software. I wanted to draw this up because I wasn't quite sure what length of carriage I would need in order to get a 0 to 10 degree angle cut on the Accu-Slice system. And I drew it up so that it's animated, so I can see exactly what the movement of the carriage is going to be. And these are the various components. The gray table there is the bandsaw table, and then that vertical band is your bandsaw blade. That long gray rail is the Accu-Slice rail. In this case, it's a 60-inch long rail. And then the yellow or gold colored plate is the carriage, which rides on the rail. And then I added an angle iron. That's that gray piece in the center at an angle. That's the angle iron, which will be bolted to the carriage, and that'll be adjustable so you can adjust the angle from 0 degrees to 5 degrees. And then the board will clamp to that angle iron into the board or to the carriage. And I had to develop some clamps to enable that to be clamped to the table and to that rail. And this shows the actual movement of the carriage with the rail and a board attached to it, which will slide halfway through your cut. Then you need to turn the board upside down to cut the other side. Okay, let me briefly describe the system I developed. It basically consists of my Accu-Slice index table, and I am using the larger table. This is the model 266, the larger index table, with the indexing wheel. And then I have my 30-inch Accu-Sled 2 carriage, and then I mounted this what's it, a 1.5 inch angle iron, actually aluminum iron, to the plate. And it has 3 screws holding it to the carriage. And the 3 screws are attached to 3 of these brass inserts that slide in these slots. This one is fixed, which is a single hole there. And I usually adjust it, it's flush with the front edge of the plate. These 2 are sliders, so this can be slid from 0 degrees to, well, if I remove this handle, 5 degrees. So doing that, this will slide all the way to 5 degrees. In fact, you probably get actually 7 degrees out of it. So that definitely is adjustable. So you do this by adjusting this, putting this on position here. As you tighten it up a little bit. Then I get my digital protractor, zero it out. And then set it to my 3 degrees. And then adjust my angle using this front edge. That's my one surface. In fact, both handles are in the way. These handles are just screwed in the various slots on the table. You can move them any place. But I adjust this by putting the front edge against the front edge, and adjust this to my 3 degrees, and then adjust the angle iron to that same 3 degrees, and then adjust it to 2.5, 3 degrees, whatever you want. And then once you have that set in place, then you just lock these two screws. And go back and make sure this one is tight. So that gives you your taper for making your various tapers. And this just slides on the rail on the Accu-Slice system. Now this is a 30-inch carriage, so you need at least a 5-foot rail, preferably a 6-foot rail. This is a 5-foot rail, it just fits. But if you're cutting anything over 30 inches long, you want to be a 6-foot rail. Then I needed some way to clamp this to the index table, because there's only a small amount of table here that the board's clamped to. It's divided by board, and it's clamped to this table. There's a very, very small edge in that front area that it clamps down to. So my first thought was to use some C-clamps. And I was going to get some C-clamps and clamp it on, here and here. But I only could clamp it down halfway. And so this front edge, would wobble and shake a lot. So that didn't work. So that's what I came up with. And I also had to worry about, cutting into the C-clamps accidentally if you happen to push the carriage too far. So I came up with these clamps here. They seem to work pretty well. A piece of aluminum with a hole in it, and then I bent it at a slight angle, and that's what clamps down and holds your board on here. And you can make these, different depths and different heights depending on which your thickness of your board is and how wide it is. When I'm cutting that one board, where you have to cut real close up here, I have almost no space up here, and here I have like maybe a 1/4 of an inch space between where the blade's going to cut and the board. So that's why this is moved back this far. There's no clamp up here at all. The clamp is back here about 6-8 inches from the edge of the board. And you just get these clamps, clamp them down. These blocks are screwed to the angle iron, and then these clamps are actually wider since I have more meat here to clamp down to. So I can make these actually wider. If you look at the depth, this is about, a 1/16 of an inch from the fence. This is, a 1/4 inch. This is, 3/8, and this is maybe 1/2 inch. So it goes out progressively. So you get good clamping. Get good clamping out here and somewhat good clamping on this edge, but it does work. So there's 4 of those to clamp the board in position. And then once the board's clamped in position, you adjust, where you're going to cut, and you can use your index table and your miter and your release your mag jigs. Use your index wheel to move it forward to get minor adjustment. So that works pretty well. The other thing I was trying out is this block here. This is a piece of plastic. It's held on with magnets, so it's pretty strong. But this is a plastic block with 2 magnets on, and it goes on this side of the blade. And the whole purpose of that was to give me some additional support. Because I'm cutting this part of the board off out here, there's no table to support it. So I thought this would give me some additional support. But in testing it, which I just finished, I'm not sure it's needed, but it's an option that you might want to consider doing something like that in the future if you start having a problem with vibration. But I really didn't see any issue because the main part I'm concerned about is being clamped to the table. So I don't think it's necessary, but I did make it to try it out. So that's pretty much it. The components are the index table, the carriage, 30-inch carriage, of at least a 5 or 6 foot rail, and this special angle iron with the clamps that I made. So that's all components that needed to make this work. So in the later part of this video, I show actually cutting this, this actual V, which came out quite nice, worked quite nicely. Now I used a 1/2 inch wide blade, 8 teeth per inch. I'd recommend probably going to a 1/2 inch wide blade, 10 teeth per inch. The more teeth per inch, the smoother the cut. But I was using this blade for something else, so I just left it on there. But I think you get better results with a 10 teeth per inch blade. Get a smoother cut, I should say. And I set this that this is on flush with the front edge of the carriage up here. This can move back and forth. So if you want to cut thicker boards or something, you can move this whole carriage back. But right now it's set that this edge is flat against this outside edge on my carriage, and this side is back whatever distance I need. These are just little angle iron clamps. I loosen up the clamps a little bit. And I can push it underneath, so it's underneath the clamps now. And I've been positioning this so that this gets flat against this front edge on this angle iron. And then I can push this tight against the angle iron. And the angle iron and this table are perpendicular to one another. And as long as your boards are square, it should be pretty accurate. But you want your boards to be square. Clamp the front down, and I clamp the back down. And notice these clamps have different lengths. This is a short one and this is a long one, so this clamps out further. But the idea is that, and this is the cutting of the blade. And this laser beam is pretty close, pretty much shows the exact angle I'm going to be cutting. So as I move the table, you can see how it's going to move back and forth. If I was to cut right there, you can see how far it's going to cut. Likewise, when I'm cutting the pointed piece, I put it like that. But this next, I'm going to make that inner cut. And I adjust it that I do not cut into this rail. So I just miss that rail. And I can use my indexer here to move it in, thousandths of an inch at a time. It's right there, right on the edge of the board, but I'm not cutting the rail. In making this cut, I want to cut halfway through the thickness of the board. So I did put a line on the board, which is probably pretty hard to see, but it's right in the middle. And I'm continuing the bandsaw blade down until it's exactly halfway through the board. And then pull it back. And to cut the other side, I get to loosen my clamps. I'm going to turn this 180 degrees. Push it up against the edge here. Clamp it in place. And I'm pushing the board tight against the rail or the fence here. The same thing on this end. Because you do want it tight against the rail and tight against the carriage. And looking at that first slice on this board, it wasn't quite halfway through the board, so I'm trying to put it back on to see if I can cut out the remainder of the distance. And this is the finished V-shaped cut on the end of the board. Okay, I moved the camera a little bit to get a little different angle and turn some additional lights on, so it's going to be a little harder to see the laser beam. I also took this spacer off. I'm not sure it's needed, so I'm going to try it without it this time. So I have another board. I'm going to do the same thing as before. Slip it under the clamps, bring it up to the front edge. Now clamp this front edge, clamp the back edge, and then clamp the middle. What I did there is that these are locked. This indexer moves this carriage in and out. So I can adjust this in thousandths of an inch increments. So I just moved it in. So the blade just missing this rail. And once it's set, then I lock these in place. This locks the table down to the bandsaw table, reduces vibration. And I'll try and cut to the middle of my slot there. Again, I will just do the other side. And just move it towards the front here. Now I'm making this second cut. I'm going to go the whole way down till it meets with the other cut on the other side, which should be halfway through the board. Now you won't get a perfect point on this. It'll be the point will be actually the width of the bandsaw blade. And I got a much better cut there that time. So what I'm doing is I'm bringing it up, bring it under the clamps. I'll bring it up. I'm going to bring it up just to the edge of the carriage here. And then lock it in place. And the clamps push it down against the table here. And I'm using my laser beam because that shows me where my bandsaw blade pass is going to be. This is actually demonstrating a single taper cut. This is the type of taper cut you would normally do on a table saw to make tapered legs on a table. Take this, reverse it 180 degrees. Now this is where I'm concerned. There'll be a lot of vibration out here. That's my one concern. So I just have 3 clamps holding it. This one's not doing anything. And there we go, there's our pointed piece. Here's a piece I cut previously. Let's see how they fit together. And that's really nice. Like that's almost so small. Now the other thing you could do here, you could actually, instead of cutting this to a perfect point, leave a 1/16 of an inch on the edge, and then it would rest flat against the bottom. But that's pretty good. Okay, this jig has other applications. You know, customers also have need to make taper, like they're making tapered legs for a table. This jig could be used to make tapered legs. So this jig will have other applications. So now I'm ready to cut some good wood using this system. And I have 2 boards here. I have a piece of padauk. It's about 1 1/4 inch square. And then this is some Spanish cedar. So there are 2 contrasting woods. I'm going to make the pointed piece on this piece and the inner groove on this piece. Made a few other changes to the system. I have put some larger knobs on here. The other knobs are a little bit small, a little hard to turn. These are a little bit bigger, so a little bit better, easier to turn. And I also installed a new dust shield. This is a brand new dust shield I just developed, which I'll be doing a video on in the near future. It's for a 4-inch hose, much bigger system with a bigger vacuum system, so it should do a good job of sucking the sawdust from the system. So we're all set to set this up now and give it a try. So always move it back, away from the bandsaw blade. And I am cutting the inner one, so I'm going to cut this so it's going to be just on the edge here. For this board, I'm going to change the angle to 4 degrees. And so this is my pivot point. I can loosen it up a hair. And then loosen these 2 screws. And these have slots in them, so they can move this from 0 degrees to about 5 degrees. So right now I'm setting this to 4 degrees. So I can move this back and forth. You can see the movement here, back and forth, to whatever angle I need. I set my gauge here to 4 degrees. Use my front edge here as a guide. And it's got to move over some more. And then I tighten the 3 screws on the rail. So that'll give me a 4-degree angle, a little bit shorter wedge. The previous one was about 15 inches long. This one should be a little bit shorter. Okay. Reinstall my handles, and then we're ready to cut. And I set my board here so it's just at the front edge of my angle iron here. And my blade is going to miss the carriage completely. So I just set that so it's flush with the edge. Tighten this first clamp. And the laser beam shows me that the bandsaw blade is not going to hit this clamp. Then I tighten up the bottom one, and then I can tighten up the middle too. I set my blade, you can see right now the blade is actually hitting my rail. So I loosen my mag jig clamps, and I move it back. And they're just on the edge of the board there, but missing the angle iron. Then I can lock that in place. And now we're ready to cut. That new vacuum system worked like a charm. This new 4-inch hose is a lot more powerful. Okay, now I got to turn the board upside down and cut the opposite side. And there's my cut. Now I'm slicing the Baduk board to a pointed surface, and by not moving the jig at all, I get the exact same angle. Okay, here's my two pieces, and since my blade here is what, 50,000 of an inch wide, or probably 45,000 of an inch wide, and get to a sharp point. It's not really a sharp point, it's a flat edge, and I really don't have a file small enough to clean that out. So what I did is I ground this edge here flat to the thickness of the kerf of the blade. So now these two should fit together. Perfect. And that's my resulting joint. So let me go ahead and glue this up, and that should be finished. I mounted this new joint in my lathe. I cut it a little bit shorter so it fits in my lathe here. I just want to turn it to see what it looks like when it's turned down. But it came out pretty nice. Here's my nice tight joint. And here's the finished turn joint. This concludes the design and testing of this new jig for making tapers on the Accu-Slice system. This jig could be used for making tapers on boards for making tapered legs. It could also be used for making these unique tapered joints. Currently this tapered jig is not in production for sale. However, get special requests from customers, it will be available in the near future. If you have any other questions or concerns, as always, please give me a call or drop me an email. And thank you for watching this video.